Hi guys, I just wanted to go over some stuff from the workbook, which we didn't get to do in class. So I'm on page 70 right now in your workbook. This is section 4.1, which is entitled Sampling and Surveys. So let's take a look at a couple of these right here. So right here, first of all, the purpose of sampling is to provide us with information about a population without actually gathering information from every single element of the whole group. All right, if we got it from every single element, that would take a lot of time, it would take a lot of money. So we sample. A sample is a part of a population from which we collect information. So right here, this will also help you with the vocabulary terms right there. But of course, you can always get these from the slides or the book. Probably the easiest way that way. This information is then used to infer something about the population. We can have more faith in our inference if we are confident that the sampling method used is likely to produce a sample that is representative of the population of interest. So you want a sample that's representative of the population of interest, and that will allow you to have more faith in your inference. Sorry about that. So let's see here. Some sampling methods may introduce a level of bias into the situation that could cause us to make an incorrect inference about the population. It is important that you clearly identify the population of interest and describe whether or not the sampling method is unbiased. So we always want to state what's the population of interest, and oftentimes right here we need to know, describe if the sampling method is unbiased. All right, let's take a look at the first example. A publisher is interested in determining the reading difficulty of mathematics textbooks. Reading difficulty is determined by the length of the sentences and the length of words used in the text. Researchers randomly select 10 paragraphs out of the most popular Algebra 1 textbooks and calculate the average sentence length and average word length for that type of mathematics textbook. So the whole population, the whole thing, is just going to be all sentences and words right here. All sentences and words used in the Algebra 1 textbooks. That's what we're actually measuring, all of the sentences and all of the words from the Algebra 1 textbooks. The sample is what we're actually going to be doing analysis on. So the sample is the sentences and words in these 10 randomly selected Algebra 1 textbooks. All right, so make sure you just are specific. Don't just say, population is the textbooks, the sample is the 10 randomly selected textbooks. Actually, the population is all of the sentences and words in the Algebra 1 textbooks. The sample is these sentences and words in the 10 randomly selected Algebra 1 textbooks. Okay, that was pretty easy. Let's move on from here. Okay, so now right here, the key to sampling is to use a method that helps ensure that the sampling is as representative of the population as possible. Because sampling methods like voluntary response, all right, we went over that in the slides, and convenient sampling can systematically favor certain outcomes in a population, we say they can be biased. An unbiased sampling method is one that does not favor any element of the population. So unbiased means it does not favor any element of the population. We rely on the use of chance to select unbiased samples. The easiest way to do this is to select a simple random sample from the population of interest. One way we could select an SRS would be to write out the name of each individual in the population on a piece of paper, put the pieces of paper in a hat, mix them well, and draw out the necessary number of slips for our sample. All right, so we took every single individual, put it all in a hat, and then we draw out the necessary number of slips that we need for our sample. We could also select a simple random sample by labeling each individual in the population with a number of the same length. Example, one digit, two digit, or three digit numbers depending on the size of the population. And then generate random numbers from technology or a random number table until you reach the desired sample size. In class, we did a random number table, all right, but there is a way to do it as a random number generator to use your calculator to do that. The labeled individuals that match the generated numbers, ignoring repeats, make up the sample. So make sure when you're describing right here that what you're doing, make sure you say that you want to ignore repeats. Make up this sample. Okay, so let's take a look right here. All right, so we have right here, an alphabetized list of names is found below. Use the random digit table provided to choose an SRS of 4 individuals. Clearly indicate how you are using the table to select the SRS. Okay, so first of all, this actually indicate our steps, and then let's actually do it. So first, what we're going to do is we're going to assign each person a 2-digit label from 01 to 23. Now, how did I know it was going to be 23? Well, if you count right here, this is a total of right here 23 names. All right, 23 individuals, I should say. All right. So right here, we need to actually label all of the individuals with a 2-digit label from 01 to 23. So right here, we're going to assign each individual a 2-digit label from 01 to 23. And remember from the slides, I said the steps are label, we randomize, and then we select. Okay, this is kind of our general game plan right here. All right, so we're going to label each individual. Now, the reason we did 2 digits is because right here we have up to 23. If we only had from like 1 to 9, we could get away from just doing 1 digit. But we have, if it contains at least 10 or more, we want to do 2 digits right here. All right, so let's see here. Next, we are going to read 2-digit numbers across the random number table until 4 of the labels are selected, ignoring repeated numbers and any labels from 1 to 23. So right here. And then right here, so we are, so right here. Next, we will read 2-digit numbers across the random number table until 4 of the labels are selected. And remember right here, ignoring repeats or any number that's outside 1 to 23. Sometimes the book will say like ignoring numbers from 24 to 99, but I find it easier just to say ignoring anything outside of our actual what we're looking for right here, 1 to 23. Either way is okay. Okay, right here. So let's go and actually do this. All right, let's look at an actual example. So first we'll label right from 1 to 23. Let's go ahead and do that. Okay, got it. It's right here. Then we're actually going to look at our table of digits, which is this is our table of digits right here. All right, so what we need to do is we're just going to we're going to read this as 2-digit numbers right here. So let's see here. First, we have 19 right here. Now, is 19 from 1 to 23? Well, yes, it is. So we're going to go ahead and select 19. Let me use a different color here. It's just not really working. Let's try this one. Okay, so we're going to select 19. All right, 22. Is that good? Yes, actually it is. All right. Usually you have to throw a lot more out here, but 22 actually worked right here. Next we have 39. Nope, doesn't work, right? 39 is not from 1 to 23. So that is, we're going to throw that out. 50. No, not from 1 to 23. 0, 1 to 23. Cross it out. 34. Nope. 5. Is 5 right here, sorry, that covered up right there, is 5 from 1 to 23? Yes, it is. All right, here we go. And then most importantly, who cares about the numbers? We'd actually just have to go and find out who are these individuals that we selected now. So we have Preble, we have Knott, kind of like the actor Don Knotts, and then 5 we have Andresen. And we're good. All right, there we go right here. So that is how we actually indicate a simple random sample and actually do a simple random sample right there. Okay, guys, I'll do the next part in a different video.